With experience, when we look at this question, we quickly see algebra, specifically a system of linear equations. This is a classic word problem in which algebraic statements have been expressed in English. Most likely, we will use the n variables n equations rule here. Namely, we are missing the number of mackerels and the number of tuna. If we can form two distinct equations with those variables, we'll be able to solve for both variables. Let's go on to the statements, which we'll look at separately first, as always. The first statement gives us the following equation. T equals 2m minus 5, if t is the number of tuna and m is the number of mackerel. This is a great equation, but we have only one total and we have two variables. So the first statement is insufficient. Looking now at the second statement all by itself and forgetting about the first one for now, the second statement gives us the following equation. Once again, it's an equation about the number of tuna, the number of mackerel, but it's a different equation. 1.5t plus 1.8m equals the total amount of money. This again is a perfectly good equation, but statement 2 all by itself only gives us one equation for those two variables. We're not going to be able to solve for m. Therefore, statement 2 is also insufficient. Putting the statements together, we have two equations for two variables. We'll be able to solve, in general, when we have two equations for two variables, if those equations are linear, meaning neither of them is squared, for example. What we can solve in this fashion, for example, by substitution. We can solve by putting the value of t, 2m minus 5, into the equation in statement 2. Then we'll have an equation just with m's in it. We'll be able to solve for m. Therefore, together, we have sufficient information to solve. We don't actually have to solve on a data sufficiency question, as long as we're confident that we can. The correct answer is C.